You know those little glitches in your thinking? Those weird gut feelings that just turn out to be completely wrong? Have you ever wondered if that's a design flaw in the human brain? Or could it actually be something much smarter? Well, today we're going to dive into the fascinating world of cognitive bias and try to answer that exact question. Yeah, this really gets to the heart of it. Why do we see winning streaks in what's actually just random chance? Or why do we get that feeling that we knew all along how something was going to turn out? It turns out there's a name for these things, and they affect every single one of us every single day. I bet these look pretty familiar. You've got the hot hand fallacy. That's why we're so sure a basketball player on a roll is going to sink the next shot. Then there's hindsight bias, that classic I knew it moment after a big event. And the conjunction fallacy, which is a weird one that tricks our brain into believing a more detailed story is more likely than a simple one. For decades, scientists had what they thought was a pretty solid explanation for why our brains do this stuff. All right, so the first big idea was the mental shortcut theory. This was the original diagnosis for all these mental quirks. It basically framed them as errors, as bugs in our brain's software. So back in the 1970s, two legendary researchers, Amos Tversky and Daniel Kahneman, they defined cognitive bias just like this, as a systematic error in judgment. And that word, systematic, is key. This isn't a random slip-up. It's a predictable, repeatable pattern of irrationality that seems to be baked into all of us. The big question, of course, was why? Well, the thinking goes back to this concept called bounded rationality from a guy named Herbert Simon. And it's actually really simple. The bottom line is we aren't supercomputers. In the real world, we have to make decisions with limited time, we never have all the information, and let's be honest, our mental energy is finite. We just can't sit around and analyze every single detail of every choice we make. So our brain's solution to this problem is actually kind of brilliant. It creates mental shortcuts, the technical term is heuristics, to help us make decisions that are good enough and fast enough. You can think of them as mental rules of thumb that let us get through the day without being paralyzed by endless analysis. Now, what's really cool is how researchers actually proved this stuff was happening. Their method was so clever. They would give people a problem that had one single, logically correct answer based on statistics. Then they'd compare people's intuitive answers to that correct one. And when they saw lots and lots of people getting it wrong in the exact same way, they knew they'd found a bias. Then they traced it back to whatever mental shortcut was causing it. And they identified a few of the main culprits. The representativeness heuristic, well, that's just a fancy term for judging something based on how well it fits a stereotype. The availability heuristic is why we're more afraid of a shark attack than a car crash. The dramatic example just pops into our heads more easily. And anchoring, oh man, this one gets all of us. That first piece of information you see just acts like a heavy anchor for all your future judgments. These shortcuts usually work, but when they don't, they create these biases. But is that the whole story? Well, this is where things get really interesting. A whole different school of thought popped up, and they argued that we were missing a huge piece of the puzzle, the environment. Maybe, just maybe, the problem isn't a flawed mind, but a mismatch between the mind and the world it's trying to navigate. And this table perfectly shows the two competing ideas. You've got the original heuristics and biases camp, which focused on errors and saw the mind as flawed. But this new perspective, sometimes called fast and frugal heuristics, focuses on the environment and sees the mind as more of an adaptive toolbox. It completely flips the question from why do we fail to the much more interesting, when do our mental tools actually work perfectly? Herbert Simon himself came up with the absolute best metaphor for this. He said that rationality is like a pair of scissors. One blade is our brain's abilities, but the other blade is the structure of the environment we're in. And you can't understand how scissors cut just by looking at one blade, right? You have to see how the two blades work together. And this leads us to this really powerful concept called ecological rationality. The big idea here is that a mental tool isn't inherently good or bad or rational or irrational. Its success depends completely on whether it's a good match for the environment it's being used in. A hammer is an amazing tool for a nail, but it's a really terrible tool for a screw. Let me give you a perfect real-world example of this. UPS. They came up with a simple heuristic, a rule of thumb for all their drivers. Avoid left turns whenever possible. Now, in an environment like the United States, where you drive on the right side of the road, this strategy is absolutely genius. It saves millions of dollars in fuel and makes routes safer. But take that exact same tool, that same rule, and try to use it in the UK or India, it's a complete disaster.
The tool didn't change, the environment did. So if the environment is so critical, that raises a really profound question. What happens when our mental software was written for a world that doesn't really exist anymore? And this brings us to our third big idea, our ancestral programming.
This is the idea of evolutionary rationality. It suggests that our brains aren't just tuned for tweeting and online shopping. They are deeply, profoundly shaped by the survival challenges our hunter-gatherer ancestors faced for hundreds of thousands of years. We're basically running ancient software on modern hardware.
Okay, let's go all the way back to the hot hand fallacy. That belief that if a basketball player makes a few shots in a row, they're hot, and they're more likely to make the next one. Statistically speaking, if each shot is an independent event, this is an error in thinking.
So if it's statistically wrong, why does this feeling stick with us so powerfully? Why does it feel so right to believe in streaks, whether we're watching sports or standing at a roulette table? The evolutionary perspective has a mind-blowing answer. Our brains didn't evolve in a casino. They evolved in the natural world. And in nature, the things that matter for survival, food, water, prey, are almost never distributed randomly. Instead, they're aggregated, they're clumpy.
Just think about it. If our ancestor found one berry on a bush, they didn't think, well, that was a random occurrence. No, they assumed the whole bush was loaded with berries. If they found one animal at a waterhole, they assumed more were nearby. Success predicted more success. Resources came in clumps.
So, here's the crucial point. For our ancestors, expecting streaks, believing in a hot hand, wasn't a cognitive error at all. It was an incredibly smart, life-saving survival strategy. The default assumption that the world is clumpy, not random, kept us alive. And that brings us right back to our original question. Is cognitive bias a bug, or is it a feature? And when you look at it through this new lens, the answer becomes pretty clear. It's a feature. What we call a cognitive bias isn't some kind of universal flaw in our thinking. It's simply a mental tool, one of many in that adaptive toolbox we talked about. It's a piece of programming that was incredibly effective for solving a specific kind of problem in a specific kind of world. And this table just lays it all out perfectly. When you use the mental tool expect clumps in the environment it was designed for, foraging in nature, the result is success. It's an adaptive strategy. It works. But when you take that exact same mental tool and drop it into a modern, artificially random environment like a casino, the result is what we call a bias. It becomes maladaptive. The tool isn't broken, it's just being used in the wrong context. So the final takeaway here isn't that our brains are flawed. It's that our brains are ancient. And that simple fact reframes this entire conversation. It leaves us with a much more powerful and, I think, much more interesting question. Knowing that our minds are so beautifully adapted for a world that's long gone, how do we become better architects of our future? What new mental tools do we need to build? And what kinds of environments can we design that work with our ancient brains instead of constantly working against them?